Hello everybody, Brian here from quantlabs.net. Once again, I believe we are on Forbes, Forbes.com. Here, NVIDIA introduces Titan 5. Is that the right number? I always get my Roman numerals mixed up. But anyways, Titan for machine learning acceleration on the PC. Now, I'm not going to go into the technical mumbo jumbo of this, but targeting machine learning scientists, I think these are for people that have more money to burn, that just wants to get the latest and greatest, because we know within 3 days of this release there'll be something new to beat it. It's typical technology, how it moves. So right now it's a heavy-duty matrix with, I think it's card like $3,000 or something. I was just at an Apple store, and you know, Apple just released a system for the Mac Pro 18 core. Ooh, you know, seriously. So there's this Volta NVIDIA architecture, whatnot. I'm not sure, and again, it's for quote unquote deep learning and API applications. So I'm not sure what this really means. I'm not sure how many processes that this will give you. As far as I know, when it comes to simulating the markets or doing Monte Carlo simulations, that's great for this type of processing. But always remember, and I'm hoping that NVIDIA has fixed this problem a few years ago, when you're trying to take your data and to move it from the CPU to put it on the GPU, it takes time. So hopefully that architecture's been fixed, but I'd be very interested to know. I'm not up to date on this as of yet. I got other things on the go, but it's very difficult, as you know, to stay on top of this anyways, but let's figure this out. Okay, so the card provides twice the energy of and efficiency Pascal, whatever that means. Allows major boosts in FP32 and FP64 performance. Also supports the new tensor cores, so I'm guessing that's really built for TensorFlow, for the machine learning library from Google, which is open source, thanks to its independent parallel integer and floating point data path. And fabricated on ground-breaking TSMC 12, FFN FinFET, NVIDIA high performance, Volta 12 gigabyte HBM2 memory subsystem. That's quite a bit of memory, to be honest. By combining a new memory, can actually guarantee 1.2 times delivery memory bandwidth, along with as much as 95% hardware bandwidth life while running multiple workloads. Done a great job with Titan, deep learning, Now it was designed for researchers. Okay, so I guess it's really designed for something like for TensorFlow. So very interesting to know this. Now, I've always challenged people on this, because when you look at something like Redis Labs, because for me, to have everything in memory, and if the library of CUDA is built like haywire, which it kind of can be, and arrays that go crazy, it puts your coding into a hornet's nest, and that's really what it comes down to, is the style and the architecture of your coding to get this working and to really optimize it. So I'll give you an example. Right now, my strategy was embedded within the Duca's Copy J4X platform. All it worked was with internal arrays, and it was just a real beast to work with. I mean, I understand that I'm gonna throw a lot of, or I should say overload the processor with too many queues, and obviously the system can't handle it. But the funny thing is that when I put on replace all the arrays and multi-threading with Redis and just doing database calls, it seems to, you know, offload a lot of that processing on this basic laptop I've got, which is a Mac PowerBook. So that is something I've always wanted to know. But if you really boil it down to flash memory on Redis Labs, with Redis No SQL, which I absolutely love. Let me just find the article here. There is an article with IBM. No, let me just find this. This came out a few years ago, so I'm sure that things have improved. But what they did a few years ago was to be able to build out a system that's built on flash memory, on RAM and flash memory from IBM. That's obviously um, built, called an IBM No SQL data engine on a Power 8 set of servers. They were able to get up to 4 million transactions or operations per second on a standard IBM box. Okay, now these boxes are worth $17,000 when I last checked, which was like a few days ago. Now, with Redis, you're getting 2.4 million operations per second on a standard 86 server. And this new server, the Power 8 box, will give you 96% to 67 higher throughput when pushing it through a Redis cluster. So let's see more stats. Combination of RAM, IBM Flash is optimized for higher throughput than commodity flash, deliver 200% higher throughput up to 70% operational costs. So it comes back to the question of when you get hardware of these NVIDIA cards, yet what is the throughput to get to the level on the actual GPU versus having the Redis SQL sitting on the server on the flash memory with direct access to Redis and the power of Redis, and having it redundantly built where you can not just have it on one box, but you can then chain them together through a Redis NoSQL cluster. And on top of that, you get the redundancy built in out of box with Redis. So again, the question is, what is the difference between if you're using a machine learning algorithm like this versus these cards, which will get outdated very quickly. Not only that, if you're using it in a production environment, if you look at these IBM Power 8 servers, yeah, they are hardware and they are expensive, but when you are moving into this area, you have to also understand is that if this thing dies, this NVIDIA set of cards or whatever they are, die, what happens to the service? Where do you go to get that service on site? Well, guess what? With IBM, as because IBM is pretty well the standard when it comes to mission critical hardware, especially at banks or government or military or whatnot, IBM will be your choice. Why? Because they've been doing it for decades. They've been doing it since the 50s, let's say. How long has NVIDIA been around? Now, here's the other thing is when your cards, your hardware fails, you have the ability to have IBM come on site and fix that hardware as part of the guarantee that they have for their hardware. I find that is very important when it comes to pushing your data through at a high throughput, as in this case, 4 million transactions per second. Now, I need to remind you, even though this is Redis Labs and they are a commercial company that are building extra services and layers of professional whatnot on top of Redis, but the Redis itself is open source, meaning it's not commercial, it's not proprietary, whereas opposed to, guess what, NVIDIA is. Now, with Redis, it gets better than that. If you are aware of Redis 4, which now have modules. So Redis 4 has these modules. So if you want to learn about machine learning, there is a set of modules coming out that are customized from a small group of folks. But guess what? With these Redis modules, this is very, very interesting area to investigate or explore. So what I'm saying though is even though you have a machine learning box with this fancy NVIDIA and stuff, doesn't mean it's better, doesn't mean it's going to give you the mission critical support that you need. Whereas if you're using something like a Redis, let's say, we're on the hardware level, as opposed to, okay, this is commercial, very powerful stuff. But again, this is open source. So for in this case, we have machine learning model server on Redis. So here's, now again, I'm no expert on machine learning, but here's the types of features that you can do: is matrix operations, logistic regression, linear regression, decision tree, ensemble, random forest classification, and regression. I'm sure there's other ones, but remember that C, our Redis is written in C. This is going to be written in C as well. As you go into the source code, you can see here, here's the C source as well as the header files that you need. So again, you get everything open source. And then all you got to do is build your module on top of the Redis, sitting on top of your flash cards, flash memory, and you're off to the races for a pretty kick-ass system with, again, I need to remind you that this is a few years old. At that time was 4 million transactions per second. No database is as fast as this anywhere. And you're getting also out of box, ready to go, your redundancy and replication if you need it, whereas opposed to these NVIDIA things and TensorFlow and blah, blah, blah. That's fine and good, but you're going to run into all kinds of speed challenges and whatnot. But for me, I like my Redis, and this is the reasons why, because I'm showing you the things that I like with Redis. Now, let's talk about my next strategy. Or let me just, before I hold off. Okay, so there's two things that you need to understand. So there's two projects right now on Redis Labs. Let me just go through. I haven't stayed up to date with these. Okay, so we know about this Redis ML. Okay, so we know high level what it does. We also have another one from the creator of Redis, again in C. He introduces a neural Redis, which is a neural network, which he advises is not to be used in production, but you can build your own modules for your own proprietary needs, I guess, for sitting on top of Redis. So again, there is some examples here for that. Now, here's the Redis ML, 13 times faster than Spark, let's say. But again, I can't really go further than that. And then, of course, here's the press release for that one. So I just want you to understand that. So where am I going with this? Even though I am very interested in learning about machine learning, I will probably maybe learn TensorFlow, but my ultimate end goal is to get onto the Redis Labs or Redis itself and build out an entire architecture using Redis as my data hub, because it's proven to me to be very fast. I can put it on pretty well anything as long as it's got a C compiler, which pretty well all basic C basic operating systems have, including the Linux. All Linux distributions have GCC or CLang on top of the free BDS as well. So that means I can then run it on pure Unix as well. So with that in mind, then I can embed the Redis on top of it and build out custom trading solutions using Redis, because it's probably a more affordable way to go. As I said, it's open source. On top of now with these new modules, if they're done right, I think this is a really good direction to go, using, again, as I said, Redis as the data hub for all of this. And with that in mind, I can then build my custom trading strategies in these modules, because I can then stream data into Redis and then have either the Lua, which is the embedded scripting language within Redis, which can also be embedded into C itself. And as a result, I can do virtually all my custom strategy code logic in the module, in the Lua script, and then have it sit on top of Redis as the data is getting pushed in, and maybe put it onto a high availability flash memory hardware solution with a basic Linux system on top of it, on top with all the connectivity into the net or the internet with that. So that's what I'm kind of looking at, and I'm going to be doing that with potentially my first trading strategy for the cryptocurrency, because I think this will be a smart way to architect your software. And on top of that, what I plan to do is I'm looking right now at maybe potentially using JavaScript as the front end for the charting and stuff, and or still using Scilab. So I'm kind of all over the place with this idea, but I'll be looking into this down the line as my next step. And I don't want to have to re-engineer everything that I'm doing because I'm struggling as it is with the Duca's copy J4X strategy, and I just want to do this the right way once, and then build all my strategies on top of it, including my connectivity into interactive brokers API as well, which is where I really want to use as my end target as my broker. All the other brokers are being questioned right now, even Duca's copy itself, with the lack of support that they offer. So that's the direction we're going. So let me know what you think. Again, fancy, I call them toys, this Titan card. Yes, the world can play around with it. That's awesome. But I do think that the Redis option is a much better option because, again, it's open source. There's no proprietary cards here that we're dealing with. The NVIDIA, which is, again, proprietary, especially the CUDA, on top of these hardware solutions, are not going to give you the production ready that something like IBM will give. Yes, you're paying a lot up front with IBM, but guess what? You're going to get the production support that you would expect from IBM when things go bad, that you can expect a IBM tech there to get the thing up and running. And that's based upon my experience working on frontline in mission critical systems in banks and pension funds. Okay, so there you go.